I'm going to give you a demonstration on how to use the Sun, Earth, and Moon visualization tool. There's a number of things we can do. We can talk about relative sizes, relative distances, seasons, elliptical orbits, lunar phases, and eclipses using this tool. We only have the Earth, the Moon, and the Sun in this tool just to make it more simple. And so I'm going to bring the orbital velocity of the Earth down to about 0. Or equal to 0, and the moon's orbital velocity down to 0 as well. This will give us kind of a comparison size relationship of the moon and the sun. You can use the mouse wheel on your mouse to zoom in and out. And if we make the Earth's diameter about 0.01 the size of the sun, then it'll be kind of close, because you can put 109 diameters of the Earth across the face of the sun, and that's how big the Earth is. So you can really get an idea how incredibly small the Earth is compared to the sun. And if you zoom in further, you get a little closer to the moon and the Earth, and it does change its size relative to the sun. So the further back, the better you get an idea of how really tiny it is. But then you can also adjust the moon diameter, and the moon diameter is 1/4 that of the Earth. So you get an idea of how large the Earth is compared to the the moon. Kind of bouncing around. Okay, the next thing we're going to look at is relative distances. Now, relative distances are going to be really tough to produce. You can estimate, because if you have 60 times the diameter of the Earth, that is how far the moon is away from the Earth. But even that's going to be tough to produce using this tool. So we're going to move on. We're going to go to seasons. So for seasons, we're going to change the diameter of the Earth back so it's fairly large. We can even make it half the diameter of the sun, just for simplicity's sake. And we can show how it's at a different angle. So for instance, right here, the angle, the tilt of the Earth, the moon corresponds, is if you have it at 0, it's straight up and down. It's aligned to a right angle to the ecliptic, and you can turn that on and off if you want to see that. But we're about 23 degrees, so let's take it out 23 degrees. And the moon just happens to be at 5 degrees off of the Earth, so we can have that one set there. We can begin orbiting the moon around the Earth if we want. And we can then start talking about seasons. So the way that the tool works is the angle is always along this axis. And we can set it in motion again. We might as well bring the distance from the sun closer so we can have a better view of what this looks like. And I also have it going into, it has an orbital eccentricity that is pretty strong compared to what it normally is. But it's good to give that idea that when the Earth is closer to the sun, it moves faster, which are Kepler's laws, and when it's further away from the sun, it moves slower. But we can, if we want it to be less eccentric, we can just turn that down. But now if we stop the Earth here, the northern hemisphere is pointing more towards the sun, and so we can see how it's darker down below in Antarctica, and up above it's light. This would be the summer solstice. And get the orbital velocity to go again, and we can stop it on this side and show how now the northern hemisphere is pointed away. It's darker, has less solar radiation, and the southern hemisphere is all light. look down below it. Or we can stop at, of course, one of the other equinox, the spring or the fall equinox, and show how the face of the Earth is fairly equal. There we go. So now we can see the line is kind of right down the middle, the equinox. This one, of course, would be going towards the summer, and so this would be the spring equinox. Okay, the next thing I'm going to show you is the lunar phases. So you can also do lunar phases here. In this case, you can kind of stop wherever you want. So I'm going to stop right here. Now we're going to zoom in, and we can take a perspective of the moon from the Earth. So let's see. Let's stop it. I have to stop the moon in this case. Let's see, orbital velocity. Let's speed it up. So if you notice, when the moon is from our perspective, you can see it's kind of a quarter moon from the Earth right there. Or you can continue it going. Oops. You could raise the diameter just to make it. Okay, so orbital velocity, bring it back here behind the Earth, and we can see that it becomes much more full when it's on the other side of the Earth. Or you can keep on going around, of course. And right now we have it to the moon, the distance. I'm going to type this in 0.25. Well, that's too close. So you can type in these fields if you want. Now in this case, if you're from the Earth's perspective, you go around here and you see that it's a new moon. The Earth is now in front between the Sun and the Earth. If you want to make it slightly more realistic, you can move the Earth back. Now, if you notice that you're not getting much of a shadow of the moon on the Earth, because only at certain times. So we're gonna look at why don't we look at an eclipse? We're gonna move the Earth, keep the Earth going around to this side. And now we're going to move the moon, orbital velocity, right there. So you can see that we have the moon between the Sun and the Earth, and so you're getting a shadow on the Earth, and that shadow, of course, is a solar eclipse. Or we can keep the moon going around to the other side, and if you notice, the moon is now black because it is in shadow. We have, in this case, the Earth's shadow is causing a lunar eclipse. So that's how you can get to display different eclipses using this tool. I think that's about all of the things I wanted to go over today.